So in this video, we're going to calculate the axis of symmetry and the vertex of a quadratic function that is written in standard form. So before we start finding the axis of symmetry and vertex of a standard form function, I'd like to discuss what a quadratic function written in standard form actually looks like. So a quadratic function that is written in standard form is y equals a times x squared plus bx plus c. So this is when we have a quadratic where everything is multiplied out and we've combined it together all of our like terms. You'll notice all of the x squared terms are grouped together, the x terms and the constants, and then you've got values for a, b, and c. And this is different from the quadratic functions we were looking at yesterday. Our quadratic functions that we looked at yesterday contained only a and c, and today we're going to look at ones that contain a b value as well. So if you look at the quadratic function below, we know this is written in standard form because we have our a value times our x squared, which is 2, our b value times our x, which is -8, and our c value, which is a constant, of 6. So we can see that everything is multiplied out. We have our like terms all grouped together, and we can easily identify a, b, and c. Now, a review of what we've learned before. The axis of symmetry, remember, is a line that essentially cuts our parabola in half, where if we fold along the axis of symmetry, we actually see that we can cut that parabola straight down the middle and fold it on itself. So for example, say that this was my parabola here. The axis of symmetry would be a line that cuts it right down the center, so if I were to fold along that line, both sides of my parabola would line up. Now, we can calculate our axis of symmetry when we have something written in y equals ax squared plus bx plus c form. So remember, this is our standard form. And what we can actually do is we can take something written in standard form and we can actually calculate our axis of symmetry. And we calculate our axis of symmetry by using the equation x is equal to -b, or opposite b, over 2 times a. And those values for a and b come directly out of your standard form. So again, we calculate our axis of symmetry by taking x and setting it equal to -b, or opposite of b, all divided by 2a. So let's practice calculating the axis of symmetry of the standard form quadratic functions below. So for each one, I'm going to start by identifying my values for a, b, and c. So here, a is my coefficient of x squared, which is 3, b is my coefficient of x, which is -12, and c is 5. So I calculate my axis of symmetry by taking x equals -b, all divided by 2 times my a value, which is 3. So here, -12 becomes a +12. My denominator becomes 2 times 3, which is 6. So I end up with 2. So my axis of symmetry here would occur at x equals 2. Now if I look at my second example, I see that I have an a value that is equal to, in this case, -1, a b value equal to 10, and there's really a +0 here, so I have a c value equal to 0. So now I have x is equal to -b divided by 2 times a, which is -1. So I have a -10 over a -2, which gives me 5. So my axis of symmetry here is x is equal to 5. So now that we've got axis of symmetry mastered, we're going to move forward and start using our equation to calculate the axis of symmetry, the vertex point, and to make a prediction about whether our graph opens up or down. So First thing we need to do is determine if our graph opens up or down. And this is all indicated by our a value here. So here we can see that a is equal to -2. And we know that that a value being equal to -2 flips our graph from the normal U shape to that upside down U shape. So that a being negative flips it so that our graph is going to open down. So that's what we would expect to see if we were to graph this on the coordinate plane. Then our next step is to calculate our axis of symmetry. And our axis of symmetry is calculated using x equals -b over 2 times a. So here I find that my b value is equal to 12. So I have x equals a -12, all divided by 2 times my a value, which is -2. So this becomes a -12 over a -4, which becomes a positive 3 over 1, or just simply x is equal to 3. So that's the first piece there, is can we find our axis of symmetry? Then the second piece here is we need to find our vertex. And in previous lessons we talked about this vertex point and how it actually relates to our axis of symmetry. So remember that our vertex lies on our axis of symmetry. So this x value that we see here in our axis of symmetry is also going to be a part of our vertex. We know that the x values are the same because the vertex lies on the axis of symmetry, so they need to share that x value. So now what we're going to do is we're going to calculate the corresponding y value that goes in our vertex. So here, if we take our x value of 3 and substitute it into x in the equation above, we have y is equal to -2 times 3 squared plus 12 times 3 minus 7. So we start with the exponent there, so we have y equals -2 times 9 plus 12 times 3 minus 7. So now we do all the multiplication, so I have y equals -18 plus 36 minus 7. Let's combine those two, so y is equal to, that's 18 minus 7, so y is equal to 11. So I would then take that y value and plug it in. So I would find that I have a vertex point of x is 3 and y is 11.